Okay, welcome to this new lesson where we're asked to find the antiderivative of trigonometric functions. Okay, now before we begin though, I'd like you to find the derivative of cos 3x. Yeah, that answer is going to be negative, and that 3 comes out the front, sine 3x. Now, because we're looking at going up or down the chain or opposites of each other, that means the antiderivative of negative 3 sine 3x is equal to cos 3x plus c. Alright, so hopefully you can see by working up and down the chain, you're going between the same function. It's just that when we do integrate this, we've got to just say that, yeah, there could be a constant tacked off the end that's being absorbed. Now, in our first example here, it's not quite the same. It's not minus 3 sine 3x. We're finding the integral of sine 3x. Alright, so let's think about what the answer would be if it were minus 3 sine x. So if it was minus 3 sine x, we'd get an answer of cos 3x plus c. Now what's missing comparing this to this? What's the missing part? Yeah, that's right, it's this minus 3 at the front. Okay, so what we would have to do to balance that out or make that minus 3 appear is we would have to, instead of timesing by minus 3, divide by 3, which is 1/3. Now don't worry, you don't have to break every question down like that. It's just a good way to think to get the ball rolling. What I've got for you is this little standard integral sheet or ideas that outlines what to do. Now if we think about this top one, which is the question we've just done, the integral of sine is negative 1 over the derivative or the a value of that bracket. Let's go and use this same idea with some other questions and see how it differs. Okay, so this next question says to evaluate. So we've got those parameters on our integral. We're evaluating the integral of sine x between pi on 2 and 0. All right, so we're going to expect a numerical answer for this one. Okay, so first of all, we're going to integrate this sine function, which means we're going to get an answer of negative 1 over that a value, which in this case is just 1, cos x. And we're going to evaluate it between pi on 2 and 0. Alright, so I'm just going to tidy this top part up a bit because that's really just equal to minus 1. Alright, so substituting, we're going to get minus cos pi on 2 minus cos 0. There's our substitution phase. Okay, to think about what's really happening here, I'm just going to draw my cosine curve. Alright, noting these halfway values here, this is an important one. It's my pi on 2, and here is my 0. Alright, so to truly evaluate this, negative cos of pi on 2, well that's just got a value of 0, minus cos 0 is going to be 1, so it's negative, so plus 1, which gives us a value of 1, final answer. Okay, example 3, and it says find the integral of cos x, but it's got this little funny symbol here. Just remember, this means radians, and that means 1 radian, which is equal to pi on 180. Alright, so what this means is we're really finding the integral of cos pi on 180 x. Alright, so we're going to use that second standard integral. It says when we're integrating cos, we're going to get 1 over that x value. The x value this time is pi on 180 sine pi on 180 x plus c. Alright, so we've really just got a bit of tidying up to do here. Remember, we've got a fraction divided by another fraction, so we're going to flip or use the reciprocal and multiply. So it's going to end up being 180 on pi sine pi on 180 x plus c. And so just to return this question to its previous form, we're just going to express our answer like so. Okay, example 4, we're finding areas again, area enclosed between that curve cos x, the x-axis, and these lines pi on 2 and 3 pi on 2. Alright, so when we're finding these areas, my immediate instinct is to do a sketch. Okay, so we're going to sketch cosine. It comes up and finishes there as so. Now we're looking for the area between the x-axes, the lines pi on 2, which starts here, and 3 pi on 2. So really we're finding this area in between here. Okay, now because it's underground, it's going to mean that we're going to get ourselves a negative answer. So we're going to have to use absolute values to get that actual area. Okay, so this area is going to be the absolute value of the integral between 3 pi on 2 and pi on 2 of cos x. Alright, so we're going to turn that negative answer positive at the end. Good thing our a value is 1, and the integral of cos is sine x. Okay, so we're just substituting in 3 pi on 2 and then pi on 2 into sine. Again, now it might be helpful just to think about our sine curve. Okay, so what this question is really getting is sine 3 pi on 2, negative 1, minus sine pi on 2, positive 1. Alright, so the absolute value of negative 2 is 2 square units because we're finding an area. Alright, I hope you enjoyed that little video. You can now go and try your homework practice questions.